Okay. All right. Cool. So let's get going. I think we've waited long enough. So, what is going on over here with activity one? Okay. Oh, you guys need one of those higher tables for us. Otherwise, we'll be bending over here. You know what I'm talking about? That whole, yeah. If I'm suffering with my height, I can only imagine the other lecturers. So, anyway.
Sorry, offend some people.
Oh, goodness. Don't do that to our visitor, please. Can't do that to our visitor. Right? So, activity one, it says the purpose of this activity is to do a complete analysis of a case study involving ungrouped data. Okay? Then there you've got the task. Okay? So here it says the following data represents the number of daily and Sunday newspapers currently published in each of the 9 provinces of South Africa. So you got 6, 18, 7, 9, 24, 12, 6, 19, and 11. Okay. Now then goes on to say calculate the mean, median, mode, number of newspapers per province. Okay. Interpret each answer. Okay. So before we can even calculate the mean and the mode and the median, what must we do with our data? We have to sort it from smallest to biggest, isn't it? So then we would say, okay, cool, 6. 6 is, yes, another 6, and then 7. What's the next one? 9, 11, 12, 16, and 24. Okay, so that's our data in order. Then we can go on to calculate the mean. And you'll see here on the side, I've just put the formulas. For those of you who may not know, you guys have a formula sheet. So why must we waste our time mastering, or should I say, cramming these formulas when we're going to be giving them? It's better to spend time practicing, isn't it? Makes sense, right? Okay, so here, this is your formula for the mean. Okay, and what does it mean? What is it telling us? The sum of all our variables divided by the number of variables. Okay, but we know average, we've done it before. So what is the sum of these variables? What is the total that we get? 6 plus 6 plus 7? What do we get? What? Ask.
I don't know if I'm seeing. You guys are doing learning unit 3, the first activity.
Yes,
right?
the first activity in learning unit 3.
So 16, I can't see 16 on mine.
You don't see 16 on yours? Oh, I also don't have 16. Yeah, I have 18. Okay. Double check. Let's double check the variables. Welcome. We are doing activity 1 in learning unit 3. Is everything okay? It's not okay. What's wrong? Me? This? What should we do? Let's deregister, then all of us can go. I can also rest. Tomorrow's my birthday, so. No, I'm so selfless that I'm going to make sure I teach you guys. So, what's the total? We're calculating the average or the mean. What's the total of all those? Or maybe I should do this so we know that these are separate. What? Activity 1, unit 3. All right. You know you got revision exercise and then you got activity. So we are on activity. You said the total is 112. Okay. Right. And then how many variables do we have? We have 9. Okay. So then what is our mean? Oh, that was an answer. 12.4. Everybody's getting that. Okay. Right. So now we have our mean. Okay. Then next formula we have is to calculate what? Our median. Okay. Our median. And there you can see we say n plus 1 divided by 2. Okay. So as you guys practice, again, I'll just suggest you print out that formula sheet and then you obviously do your thing. Okay, so we know that we have 9 variables, isn't it? So then we simply say 9 plus 1, right, divided by 2, which gives us, is that our answer? Are we done? We're done. So our median is 5. What must we do? Huh? We must look for the 5th position. How do we do that? We count, right? 1, 2, 3, 4, and 5. So our median is what? Is 11. Okay. You wouldn't be able to know exactly which position your median is in, right? Or you mean skip the counting?
Yeah, like the 9 plus 1 over 2. Like it's in the middle, the odd.
Oh, yeah, you could actually, since it's an odd number. So this is what? 1, 2, 3. Yeah, it's 9. Yeah. So you would say, okay, we've got 4 numbers here, and we've got 4 numbers here. Yeah, you can do that.
But you get marks.
One second, let me just. So, you know, sometimes when you have so many classes, you think you've said something to the one group, but you haven't actually said it to the other. Okay? If you do it this way that you just mentioned now, you'll still get your marks. That's if you get the right answer. So if for some reason, somehow you didn't have a good night's rest and you select 12 instead of selecting 11, all I'm going to see is 12, isn't it? So if I just see the 12, I'll be like, hey, I don't know where she's getting this number from. So obviously in that case, you won't get any marks, right? Because your answer is wrong. Does that make sense? So yeah, you will get your full marks if your answer is right. If your answer is wrong, you obviously lose out because that specific method you use doesn't even have workings. So I can't begin to say, oh, but she has the right formula. She just failed to give me the right answer. Does that make sense? But yes, you will. That's a long way of saying, yes, you will get your marks as long as it's the right answer. Yeah. Okay. This is why all the time your lecturers will say, just show all your working, just show all your working, because we can never really always guarantee that we'll get to the right answer. Does that make sense? Okay. Is that fair? Is that fine? Right. Okay, so we now have our median. The next thing they ask us to do is to then calculate what? The mode. Okay? Or the model. Model is what they called it here. So, how do we do that? How do we calculate that? What is the mode, guys? Yes, the most frequent number. Simple as that. What's our most frequent number there? It's 6. It's this one. Thank you, sir. Okay, so now we have our mode. Okay. We have our median, and then we obviously have our mean. Okay. So question 2 there, they say by comparing the mean, median, and modal statistics, what can you conclude about the shape of the distribution? How? What have you compared? How have you compared those three? Anybody? So here what you want to then look at is you need to rank them in terms of their largest to smallest. So here we can see that our mean is greater than our median, which is greater than our mode. Can you see that? And then we have to ask ourselves, what type of distribution would we have? Tell us, you told us just now. You were right. Do you remember? Yes. Okay, so what type of skewness will we have? You're 100% right? It will be skewed to the right, right? So remember, typically, most data is bell-shaped. So when we say it's skewed to the right, what are we actually saying? It means that the tail is on the right, right? The tail is on the right. So it would typically then be something like this. Does that make sense? That's how your data typically will look like. All right. What's another name of skewed to the right? Positively skewed. Okay, so this is positively skewed. Okay, because again, let's say if this is our 0, again, our tail is going to be on the positive side. Okay, right. And so if you had it the other way around, I'll just do it in a different color, like this. So in other words, your mode was greater than your median and was greater than your mean, then we would have the opposite distribution, which means that it would now be negatively skewed. So if I try again, you see your tail is then on the negative side, left tail. Okay, right. Anyway, enough about that. So we've dealt with now number 2. So let's go on to number 3. And I want to just continue to operate here in the center because I want to be able to use those formulas. So let's go with the blue. It says here on number 3, determine the range, variance, standard deviation, and coefficient of variance for the number of newspapers per province. Okay, so variance, S2 is your formula for variance. Okay, so I'm not going to rewrite it. Might as well just zoom in there quickly. Okay, so it's saying the sum of x squared, right? The sum of x squared minus n times the mean squared divided by n minus 1. Okay, so when we calculated the sum of x, this was equals to, so it's equals to 112 if I'm not mistaken, eh? Okay, so you square that, what do you get? How much? 800 and
No, square what? It's 12,000.
12,044. Okay, right. And then we're saying minus, here we can say 9, the mean of the variables that we have squared. So the mean, what was it again? It was 12.4 if I'm not mistaken. 12 point? So 12.4 squared, okay? Right, then divided by n minus, we know n is the number of variables, so 9 minus 1. And what I always advise is first calculate this, get whole numbers or flat numbers, and then proceed. So what do we get when we say 12.4 squared? 12.4 squared, what do we get? 153 rand, okay, then times 9, 1.3.
1.383.
Okay, just call out the numbers for me.
138.
138 3 0.84. Okay, right. And then we can find out what our numerator is and then divide it by 8. What do we get? I'm waiting for you guys.
Say it's 1395.02.
That's the answer you're getting.
1395.02.
9502.
Comma 02.
Oh, comma 02. Okay. I'm just curious about something here because I see these guys here, over here, they have 1,000. They have 1,728. I'm just curious as to how they are getting that. What is the square root? 1728. I'll just do this one. Something there doesn't seem right. Okay. All right, so anyway, let's stick with ours until I'll go and check that to see what may be the issue, if at all we are wrong. Then to get your standard deviation, it's now just the square root of what we've just calculated, okay? So that's how we get our standard deviation. So we take our 1,395, in fact, in your calculators, at least I know with mine, I first need to get my square root, then 1,395.02, and I get 37.34. Okay, if I round off to 2 decimal place, that would then be 5. Okay, and that would be then my standard deviation. But then they also ask us to calculate what? What else do they ask us to calculate? Yes.
So when we're doing previously the range, right?
The one we did previously was the variance. We haven't done the range yet. The range is the difference between your maximum and your minimum. This formula over here. Just highlight. Okay. So our maximum value, if we look at all our data, is 24, isn't it? And the minimum we know is 6. So 24 minus 6 gives us a range of 18. Okay. Right. To the formula. Okay. Stay highlighted. Okay. Happiness, we can go on. Okay. So then the next one. Where is it? Where am I? Oh, let's look at it here. The next one, we now need the coefficient of variation. All right. Coefficient of variation, we're taking our standard deviation, we're dividing it by our mean and timesing it by 100. So our standard deviation, remember we calculated it here, it's this 1,395.02. Okay, and then dividing it by our mean, we know is 12.4, isn't it? Then times 100. And what do we get? What do we get? Yes?
Is it not supposed to be the standard deviation is 37.25?
No, isn't that your, that's your, oh yes, you're right, sorry. The variance, well, this was the variance. This was the variance, sorry. It's old age, guys. It happens. It's old age. I'm a very old person, guys. You see? I told you old age. Okay? So that gives us what? Come, guys, you must be calculating, eh? We're all calculating. Okay, times 100. This is what I'm getting. And then this should be a percent. Okay? Now again, if you're actually, if we round this off, it should be 1 here. Okay. Should be 1 over there. Okay. Right. So that's all they asked us to calculate. Okay. Again, I'll investigate to see why are we getting a different variance. Okay, because obviously that means all our answers that are following are also different. Okay, in comparison to what they have in the back of your work pack. Okay, so we'll just verify that to see what, if anything, is the matter over there. But in the meantime, let's move on to the next thing that they're asking of us here. Okay, and here now they're asking us to determine the value of the first and third quantile for the data set. Okay, right. So again, before you can do your quantiles, you need to have your data in order. Okay, so just so that we are aware of that, okay, I want us to just clearly see our values again. Okay, so I think let me also just no, but I need this as a reference, so it's fine. We'll just operate at the top here. So here you can see on the side here at the bottom, you can see the formulas for your first and your third quantile. Okay, right? So it's simply n plus 1 divided by 4 to get your first. Okay, so n again we know is what? We know it's 9. Okay, plus 1, which will then obviously give us 10. So 10 divided by 4 gives you what? 2.5. Okay, is this our answer? Are we done? Can we move on to the next? Are we happy? So remember, with quantiles, we're trying to establish what? Where our data is sitting. Does that make sense? So if we have a quantile, that means that we are splitting our data into 4 equal parts, isn't it? All right? So you've got the first 25, second 25, third 25, and your final 25. So if we're saying the first quantile, which 25 are we looking at? This one, okay? So we want to know all the data values. What should they lie below? Okay. So are we going to say that this 2.5 is our answer? We can't. So we use this to locate where the first 25% of our data lies. So we then say, okay, 1, 2, okay, but we've got a half there. If it was just 2, we'd say, okay, 25% of our data should be less than 6. That would be our answer. 6 would be our answer. Does that make sense? Okay. However, we have a half. So what must we then do? We have to calculate the difference between where the 2 has led us and the next value. So we say 6 minus 7, or 7 minus 6 will give you 1. All right, then times 0.5, because that's what we are trying to factor for, isn't it? Can you see that? We're together, okay? Which will then give you 0.5, isn't it? So this 0.5 we then add to the 6. So our final answer should then be what? 6.5. And that's our final answer, okay? That's our final answer. So again, it's important for us to understand what it is that we're actually doing. We're saying 25% of our data is either equal to or less than 6.5. Okay. In fact, it should be less than, actually. Less than. So, right. So that is your first quantile. Okay. Can I move on to the next one? Fine. Okay. So we're following the same process. Again, we're looking for the third quantile now. So the third quantile, we're saying what? Are we looking for just this 25% over here? What are we looking for? Yes, we're looking for all the data between. Okay, so as you were saying, which would then be obviously 75% of our data, isn't it? Okay, the 75 bottom. Okay, very important, the positioning there. Okay, not the top, because we could say 75 also from here. Okay, but that's not what we want. Okay. Okay, right. Okay, so what's our formula? See, so if you practice, you understand your formula, you'll be good to go. Okay, so here we're just saying 3n. Okay, n we know is 9, and then plus 1, we know that's going to be 10 divided by 4 again. Okay, so 10 times 3 is going to give you what? 30. Divided by 4 will give you 7,5. Okay, so again, 1, 2, 3, 4, 5, 6, 7, and then again we've got that half. So 19 minus 18, we get 1 again. Okay, half of 1 gives you half. So it will then be 18 and a half. Is it making sense? So what are we saying? 75% of our data is what? 75% of our data in relation to this is below 18.5. It's below 18.5. Okay? Right. So we would then say, what about the top 25% of our data? Because sometimes they can make you apply this. If we're saying 75% of our data is below 18.5, what are we saying about about this 25 here. The top 25. Yes. Thank you, sir. It's either equal to or above. Because remember here we're saying below, isn't it? So it's either equal to or above 18.5. Does that make sense? Okay. Right. Okay, so that was our first and third quanta. Okay. So I think now let's just take a quick break and then we'll get back together and we'll finish this off. And then we'll at least do exercise 3 before we call it. Okay. You think it's complicated?